So before we describe the domain of a radical function, let's take a moment to define exactly what we mean by a radical function. A radical function contains at least one radical and is otherwise rational. Just about the only thing that we can think of so far that's out of bounds at this point is variables and exponents. There are other things that are not allowed in radical functions, but we haven't met any of them yet. So what I would call the typical radical function, though, looks like this. A number times a radical expression plus or minus another number is a pretty typical radical function. When will we be in the domain of a radical function? Well, the only rule that we have to follow for the sake of the radical is expressions inside even roots must be non-negative. Non-negative, what does that mean? It means positive or zero. So in our example function here, since 4 is even, we must have x minus 2 greater than or equal to 0. But we can do better than that. We can add 2 to both sides and get x is greater than or equal to 2. So the domain of f in set builder notation is the set of all x such that x is greater than or equal to 2. Or we could write that in interval notation as 2 up to infinity. Let's see a more complicated example. G of x is the radical function square root of the quantity x minus 2 divided by the sixth root of 5 minus 2x. So we have our new rule about even roots. And we also have to remember our old rule. Denominators can't be 0. So what are our rules? Well, we need to have x minus 2 greater than or equal to 0. We need to have 5 minus 2x greater than or equal to 0. And we need to have the sixth root, 5 minus 2x, not 0. Oh, but the only number whose sixth root is 0 is just 0. So we need to have 5 minus 2x, not 0. The way to accomplish being greater than or equal to 0 without being 0 is to just be greater than 0. So here I'll add 2 to both sides. Here I'll subtract 5 from both sides, and then divide both sides by negative 2. To be in the domain of this thing, I need to have x greater than or equal to 2 and x less than 5 halves. Let's take a look at that on the number line. Here's 2, and a little bit bigger than that is 5 halves. Right, 5 halves is 2 1/2. So, greater than or equal to 2, less than 5 halves. The overlap goes from 2 up to 5 halves. So, the domain of my function g is 2 up to 5 halves. 2 is included, 5 halves is not, because 5 halves makes the denominator 0. I'm going to give you one of these to try, a fairly simple one. So suppose h of x is a half of the fourth root of x minus 2 plus 3 times the fifth root of 5 minus x plus 7. Find the domain of h. And give your answer in interval notation or set builder notation, whichever you prefer. Pause the video and try this now. Alright, let's see. What rules do we have to follow to be in the domain of h? 4 is an even number, so x minus 2 has to be non-negative. 5 is an odd number. We can take the 5th root of anything we want. So this is the only rule. So adding 2 to both sides, x is greater than 2. The domain of h is the interval 2 up to infinity. Or we could write that as set of x such that x is greater than or equal to 2.